Okay, everyone, today I'll be doing the physics quiz. So first we start with question one. This is for week 5, obviously. We start with this question, right? So for this one, you're gonna need to know a formula. The resistance is equal to the resistivity, which is rho, which is in this case this one. Here, this is our rho, times the length over the area. Okay, the length is this. This is L. This is A. So now it's just a matter of substituting. So R equals to 1.7 times 10 to the power of negative 8 times the length, which is 1.5, over 1.3 times 10 to the power of negative 5. Okay, this will give you, when you do it on a calculator, this will give you 1.96 times 10 to the power of negative 3 ohms. So we'll write down the ohms like this. I don't know how to write down the ohm symbol, whatever. But however, if you notice here, all your answers in the multiple choice will be milliohms. So what you're gonna do, you're gonna remember that to change something from the unit symbol to a milli is times 1,000, right? So if you do 1.96 times 10 to the power of negative 3 times 10 to the power of negative 3, so basically you're doing 1.96 over 1,000 times 1,000. The thousands will cancel out, so you'll get 1.96 milliohm. Okay. Now, obviously, they wanted two significant figures, so you round to the second significant figure. This is gonna round to 2 milliohms. Okay, that's it. Question two. Let me just see if I'm recording my audio. Yes, I am. Okay. The ratio of the PD to conductor, blah blah. Okay. This for this one, you're going to know the formula. You're going to use this a lot. V equals IR. Okay. Now they told you the ratio of the potential difference, so you're gonna know there's a ratio, which is something over something. So V over something so far. To the current. Current is I, right? Current is our I. So this is I. So what is left is the R. You're just dividing I on both sides. That's it. R is the resistance. خلاص, that's your answer. R equals V over I. Okay, question 3. The PD across a 5 ohm resistor is 20 volts. The power consumed. Now, for this one, you're going to need to know a formula. P equals I squared R, right? For this, notice you don't have I, right? So how will you get I squared? Simple. V equals IR. Like, you're going to use this a lot. Okay, so what we have? We have 20 equals to 5I. So I is 4 amperes, right? So now what we're gonna do, power is equal to 4 squared, 16 times 5. Do it on a calculator. 16 times 5 will give you 80. So power equals to 80 watts. Okay, question 4. What's the electrical component X called? Just remember it, it's called a diode. You're gonna need to memorize the list. So let me see if I can get it. Electrical component symbols. There we go. Okay. You can memorize not all of this. We don't need all of this one. You can do this one. This one's good. It has the diode. It has pretty much everything you need. You can do this. Yeah, okay, خلاص. Just memorize this, or it's in the book. You don't even need to do this, just to be sure, يعني, because this has extra things. We didn't take transistors or source voltage connections, whatever those are. Okay, whatever. So how will the circuit flow? Obviously, circuit flows from positive, negative. So if it's from A to B, it's gonna pass through C, so it's A to C to B. Okay, question 5. This one. Now listen, when you have two circuits connected successfully, like properly, like this, see, notice positive, negative, positive, negative. The voltages here are additive, so it'll be, this will equal the total voltage or the total EMF or potential difference, whatever. At our level, they're both the same. Okay. So now if you add a resistor that's not connected in the same way they are, so like this, as you can notice, they're opposing. What you basically, it can be negative, positive, negative, positive, by the way. What it just doesn't have to be is the two negatives are facing each other or the two positives are facing each other. See here, you can connect the two negatives by a line. You don't want that. You want the negative to be connected to a positive on both sides. Here you can see positive, negative, the negatives connected to the positive and the positives connected to the negative and the negatives connected to positive, except in here where the negatives connected to the negative. So what this is going to be, whenever you have this, you're going to subtract the voltage. So it's going to be V plus V minus V. Okay, just in this case, they can add, like, for example, here they added 4, so it's going to be V plus V plus V minus V. So let's see this. This one's connected. Let's say this is V. Okay, it's connected in the same way as this one. See, negative connects with positive, so V plus V. Okay, then it's the same things here, so V plus V plus V. And then here you can see they're opposing each other, so negative with a negative, so minus V. So the negative, so then you just substitute the positive, the value, so 1.5 plus 1.5 plus 1.5, which is 4.5, then subtract 1.5, which is 3. It sounds confusing, but all you need to know, if they're connected like this, you add the voltages. If they're connected like this, you subtract. And then you just apply it to extended cells. Okay, question 6. The potential difference across an ohmic device of 50 is blah, blah, blah. Okay, so V equals IR. Now you want I, so I equals to V over R. If you want, you can remember the triangle, but like you guys should be old enough to not need it now. V I R. This is your triangle. Okay, we use this. V is 12 volts. Okay, R is our resistance, which is in ohms, which is 50. So 12 over 50 is gonna be 0.24 amperes. Ignore this, please. 0.24 amperes. There we go. Okay. Question 7. The resistivity of germanium. Same thing. You do the formula. So I'm gonna block snaps. Why do I have them? Okay, the resistivity of germanium is 0.48 ohm meter. The wire of germanium has length of 5 millimeters and a cross-sectional area of 1 millimeter squared. Now, notice here you have meters. Here meter, but here you have millimeters. And you can't change the unit of resistivity. It's going to be very hard for us to do it, right? But you can change the length. So what we can do, we can maintain it like the 0.48. We keep this one the same, times, to change millimeters to meters, you divide by 10 to the negative 3. So 5 times 10 to the power of negative 3 over uh 1 millimeter squared. So what you're gonna do, it's 1 times 10 to the power of negative 6. Think of it as you're changing millimeter to meter twice, right? 10 to the negative 3 and 10 to the negative 3 again. So that's gonna make 10 to the negative 6. So 1 times 10 to the power of negative 6. Okay, now you do this on a calculator. So 0.48 times 5 times 10 to the power of negative 3 over 1 times 10 to the power of negative 6. You get 2400. Now this is in ohms, okay? Because remember, ohm meter. So we cancel the meters out, right? Because this meter here canceled with this meter, and then you have a left, whatever. They cancel out. But you're going to be left over with the ohms. They want in your answer kilo ohms. So you divide by 3. 2.4 kilo ohms. I think I said divide by 3. It's 10 to the power of 3. So then you divide it by 1,000 basically. You get 2.4. That's your answer. Okay, so what to do for this question? You're gonna need to remember two formulas: E equals QV and what was it? Sorry, Q equals to IT. Okay, so first you start with Q since you already don't have Q. Q is the charge, E is the energy, V is the voltage. Q is equal to IT. What we have? We have the T and we have the I. 3 times 1.5, change it from minutes to seconds, is gonna be 90. So 3 times 90 is 270. Now, E equals QV. So E is equal to 270 times. Okay, I just realized we don't have the voltage. So what we're going to do, because they like making our lives harder, V equals IR. The V is equal to 3 amperes times 20. V is equal to 60 volts. Okay, 20, 40, 60. So yeah, 20 volts. So 60. So times 60. Now E is gonna be equal to, you do it on a calculator, 270 times 60 will give you 16,200. However, remember this is gonna be in joules. They're always gonna give, if you multiply the unit, like the units themselves, not with any suffixes, not kilo, mega, deci, whatever. You're gonna get the unit value for everything. So this doesn't work, right? Because we have kilojoules in our multiple choices. So what you're gonna do, you're gonna divide by 1,000, or to get it into kilojoules, you're gonna get 16.2. They rounded into two significant figures, so you're just gonna get 16 kilojoules. Okay, question 9. This one I would recommend memorizing. So am I recording the audio? Yeah, I am. Okay. This one you have to memorize. They're in the book. Oh, this is the straight line obeys Ohm's law, so we call it ohmic. This is a semiconducting diode. Okay. Where should we place the slider in order to give zero output? So this is a potentiometer. Now, a potentiometer is used to control the potential, the potential. What was it called? Potential difference. Now, what you do here, it's like this. It's connected to like a coil, I think, and then it's like this. Something like this. I'm not sure if this is accurate, but this is how I did it, and it gave me a right answer. Now, if you remember the potential difference, if you remember how this looks like, this is gonna be very wrong, obviously, but like, because this is not an accurate drawing. Let's call this A, B, C. Okay. Now, say if you go from A to C, this coil is the resistive coil. By the way, this is like how it makes a resistive. Well, I don't know, whatever. I'm not interested in the inner workings of it right now. So if you go from A to C, you're using the total coil. So you're not gonna have a difference. You're not gonna have a voltage. However, here you're using all the resistance. Here at B, there is like a certain area you're not using. So this is where this is actually useful. This application. So this is what we're basically gonna apply here. Where should we place the thing to give zero output voltage at Z, since you're connecting it in total? Where should we place the slider to give a maximum output? It's basically A to A. So you're containing your A, you're containing your voltage, and at point Y, it's because it's not using the whole area, remember? So it goes from X to Y. Again, I'm not very good at explaining this chapter. I don't like this chapter at all. I'm better at like forces, or this isn't really my thing. Okay, now for parallel circuits, you need to remember that the total resistance, we'll call it RT, or here they said equivalent resistance, to call it RE. RE is equal to 1 over R1 plus 1 over R2. Sorry, this is going to be 1 over RE plus 1 over R3 plus all the way until you get uh, R to the N. Okay, so it's just gonna be R, like, to any number. This could be R21, the 21st resistor. This is what R to the N just means. Okay, what now we're gonna do? We're gonna apply this. So let's just leave this up here. RE, I keep forgetting to put the 1 over, is equal to 1 over 30 plus 1 over 70. Because remember, we have 30 and 70. Plus 31 plus 1 over 70. Now, you do this on a calculator, obviously, because who has the time to find the common factor of or the common multiple of 30 and 70? No one in the physics exam. So you're just going to do this on a calculator. 1 over 30 plus 1 over 70 will give you 1 over 21. Okay. Now, remember, this is 1 over the equivalent resistance. So what you're going to do, you're going to flip it around. The equivalent resistor is equal to 21 ohms. That's your final answer. Okay, question 12. Two resistors of 15, 20, and 50 are connected in series. Series, the equivalent resistance of series is just going to be this. It's going to be really easy. R1 plus R2 plus R3 all the way until, as always, Rn. This is just your formula. Right here, simple. So 15 plus 20 plus 50. So Re is equal to 15 plus 50 or plus 20, doesn't really matter. Addition is cumulative. Plus 20. So this is going to give you 85 ohms. That's it. Then you're done. Okay, question 13. A 1.5 ammeter can measure currents up to 200 milliampere. In order for the ammeter to measure currents of up to 10 amperes, a shunt resistor must be connected in parallel with the ammeter. Okay, obviously, because listen, I have a trick for this and it's really useful. It helps me a lot. The ammeter connects in series with the circuit. So S with circuit. Okay. Now, whatever is happening on the outside, which is the ammeter itself and the circuit, is going to be the opposite of what's happening on the inside. So the shunt resistor and the layout. Now, this means that the shunt resistor is going to be connected in parallel with the ammeter. Remember, they're opposites, as you can see. Here is series with the circuit, here is parallel. They're opposites. What's happening on the inside is the opposite of what's happening on the outside. So once you have series, you're going to have parallel. Now, for the voltmeter, and they're going to ask this later, in the voltmeter, you connect the voltmeter in parallel with the circuit. So what you do, so V is equal to parallel with circuit. This means that the shunt resistor is going to be connected in series with the circuit, with the voltmeter itself. Okay, they're opposites. That's just what I'm trying to say here. Okay, now part B is a really long, not long formula. I wouldn't say it's actually very easy, and I'll show you how to derive it. Then I'll show you the formula itself. So if you ever get lost and you don't know how, I'm gonna make your life 10 times easier if you ever forget the formula. Okay, so what you're gonna want to do is first, you know that inside in a parallel, since here it's parallel, in a parallel circuit, right? Because we're just gonna consider this its own like circuit system. In a parallel circuit, which means the shunt resistor and the actual like screen of the ammeter, the voltages are equal. So we're gonna say this V is equal to V, right? Now we're gonna say this is the layout of the thing, right? So this is how we're gonna connect it. Here there's a coil, okay, and here is our shunt resistor. So SR, okay, they're in parallel. So if our coil is here and our screen is here, the reader is going to be like here. It's parallel as well, but we're going to consider these one system because they're connected to each other. Okay, which means that since we're going to go back to this derivation, the voltage of the full screen, which is the where the coil is going to be equal to the voltage of the shunt resistor. So, and also you have to remember that in an ammeter, or sorry, in an ammeter, yeah, in an ammeter, in a parallel circuit in general, current is additive. Okay, so IT is equal to I1 plus I2. Oh, I mixed them up. I1 plus I2 plus all the way to IN, whatever. Okay, so we expand this. IR is equal to IR. Now, this is very vague. This doesn't tell me where I am. I full screen, so the full reader of the ammeter, which is normally this, the up to, is this one. This is the full screen. Is times the resistance of the coil, since they're both the same system. You can say I of the coil, but not preferred. Is this I, right? Since addition is in a parallel circuit for the current, is gonna be I total minus I full screen. Okay, this is my derivation so far. This is where I'm going. R, this is the resistance of the shunt resistor. Obviously, I'm just going to say S. Okay, now we want RS alone. So where we are now? We are IFS RC is equal to IT minus IFS all into RS. Now the school doesn't teach you this derivation, so it's really important that you focus. In case you ever get lost, I advise memorizing the formula. You can memorize from here actually, because then all you have to do is divide by this on both sides. So we're gonna do IFS, or no, IT, sorry. IT minus IFS on both sides. I'm not gonna write down it again. I'm not gonna write it down again, but I'll just throw an arrow. So RS is gonna equal to Let me now erase this. This is where you should memorize the formula. RS is equal to IFS RC over I total minus IFS. Okay, this is our equation. So now everything else is pretty much irrelevant to us. Let me erase the derivation. If you want to learn the derivation, just watch this 20-second snippet again. Okay, now this is what we're interested in, our formula. So the shunt resistor is equal to IFS. So it is 1.5 times, I don't want to work in milliamperes since I have amperes for the I total. So here, this isn't what I want. So this is going to be 200 times 10 to the power of negative 3 or 0.2. But, you know, you might mix up if you do it mentally. Over I total is 10 minus this number here, because this is our IFS. 200 times 10 to the power of negative 3. Okay. Now what we're going to do, we're going to work this on our calculator. So my calculator is here with me. 1.5 times 200 times 10 to the power of negative 3 over 10 minus 200 times 10 to the power of negative 3. This will give you 0.03061. Let's just stop here. Okay. Now this again, because we're working in the unit, like the actual unit, not with the suffixes. We change this to the proper unit. We change this to amperes. And we have this in ohms, which is the unit, and we have the ampere. So this is going to be in ohms, right? We want to change it to milliohms. And remember, anything from the unit to the suffix milli is times 10 to the power of 3. So we're going to multiply 3 times. We're going to move the decimal point 3 times. Sorry. 1, 2, 3. So 30.6. Our final answer is 30.6 amperes. Milliohms, sorry. There we go. This is our final answer. Okay. Question 14. Now, guys, I'm actually sorry because I'm explaining really quickly. And I know my explaining is bad. بصراحة I can feel it myself. But I actually have to go soon. If you have any question, I will answer it. If you have any question, just write it down in the comments. Or some of you guys have my number somehow. So just text me on wherever you can. As you can see, I have WhatsApp, so just text me on WhatsApp. Text me. If you have my Snap, just text me wherever you have me. Okay. If the current passes through resistor C to two decimal places is okay. For this one, it's gonna be a bit complicated. I'm gonna need to focus. So what I'm gonna do first, I'm gonna take this as its own thing because I need the full page for it. Okay, we're gonna expand this. There we go. Perfect. Okay. Now we're gonna fill out the values. So the battery, let's say this is the positive terminal, here's the negative terminal, is 24 volts. Okay, resistor C is 45 ohms. Here, both of them is 10 ohms, 10 ohms. Now, what we're gonna do, because we can't work like this, this is a very inefficient way if we have this right now. So what we're gonna do, we're gonna resolve the total resistance here, and we're gonna go from there. But if you don't know what I mean, just watch what I'll do, and you'll understand. R 1 over R, sorry, I keep forgetting the 1 over RAB, because we're resolving the resistance between A and B. 1 over RAB is equal to 1 over RA, which is 10, so 1 over 10, plus, again, RB is 10, so 1 over 10. This is going to be 2 over 10. Okay, you flip it, it's going to be 10 over 2 or 5, but we're going to simplify. So this is going to be 1 over 5, which means that RAB is actually 5 ohms. This is the resistance between these two. So now what we're going to do, we're going to draw this in series and we're going to take RAB as its own resistor. Let me show it on you. So this is our negative terminal. This is our positive terminal. And the voltage never changed. We didn't do anything with it. 24 volts. So here, RAB and we're gonna go here. This is gonna be C with this is 45 ohms and 5 ohms. Perfect. Okay, so where do we go from this now? We're gonna do, because remember in a series they want us to find, first of all we're gonna work part by part, current through resistor C. Okay, in a series circuit, because now this is series, right? We change this from parallel to series, it's from a mixed circuit to a fully series circuit. What we're gonna do now is we're simply gonna calculate the current through C when it is given that this whole circuit is a series circuit. However, I'm gonna give something that's gonna make our lives 10 times easier. You should know this because it's grade 9 material. But in a series circuit, I is the same. I will always be the same. I is constant. So I will say I equals to K, because K we label K as constants. Okay. So now what we're gonna do? We're gonna do V equals to IR. Okay. This is the total resistance, mind you. So what we're gonna do? We're gonna add up our resistance. 45 plus 5 equals to 50 ohms. Okay. So now V, which is 24. So we're just not gonna write this again. 24 is equal to 50I. So I is going to be equal to, this is the total resistance. I is equal to 50 over 24, which is equal to, this gives us 0, or sorry, 24 over 50. What am I doing? IT is equal to 24 over 50, which is going to be 0.48 amperes. Now this is the total current. So as I said before, the total current is equal to the current when it is in, and for all the currents in every component device, when the circuit is in series. Okay, what this means? So that means that the current in AB in both of them, so across both of them, is also going to be 0.48. Okay, and this also means that the current in C is going to be 0.48, and that's the answer to part A. So A is for 0.48 amperes. Okay, now we're gonna go to the AB part. We're gonna split it back up again. We're gonna focus on AB by itself. Now we want resistor A. However, we can work with resistor B since they have the same property. Okay. Now, in a parallel circuit, I want to start off with this. In a parallel circuit, voltage is additive. So what we're gonna do, we're gonna subtract the voltage from this thing. So the voltage from sorry, the current is also additive here in a parallel circuit, not the voltage. The voltage is the same. I mixed them up. Okay. So V equals to V, whatever, I'm not going to work with this. I in AB is equal to the total total current, minus the current in C, which is 0.48. So IAB is equal to the total current, which, give me a minute. Okay, so I had the question wrong. What we're gonna do, my bad. So this is accurate, fairly accurate, but I don't know what that was. Why is my dad's phone here? Whatever. I'm not gonna question things anymore. We're gonna do V equals IR for this one. Then we're gonna subtract the voltage from this one to find the voltage in AB. So from the total voltage, let me show you what I mean. Okay, the total voltage is gonna be the voltage in AB is equal to, okay, that was my phone. It's equal to the total voltage minus the voltage in C. Okay, what's the voltage in AB? We don't know. The total voltage is 24, and we can find the voltage in C. V equals IR, and R is going to be with the C, so 0.48 times the resistance, which is 45. So 0.48 times 45 0.48 times 45. Let me just change that to 04 just to make it clear for you guys. 0.48 times 45 is gonna be 21.6. So the total voltage is 24 minus 21.6, and sorry, not the total voltage, the voltage in AB, which is equal to 24 minus 21.6, 2.4 volts. Okay. Now, voltage is the same in AB, right? Because voltage in a parallel circuit is the same. So 2.4 for A is equal to IA RA. Now, we have A, we have RA, we don't have IA. So 2.4 is equal to 10 IA. You divide both sides by 10. IA is equal to 0.24. And that's our final answer. Okay, my bad for reading the question wrong. I thought that was the other way around. Whatever. Okay, this one. Now, there's multiple ways of writing the expression. Give the expression that relates the current I passing through the conductor, the potential difference V, and its resistance R. Now, what I did, I read it, I thought they wanted like the whole equation in terms of I. So I in terms of the whole equation, sorry. So what I did, I wrote I equals 2 V over R, which is accepted. I got it as a correct answer. However, you can also apparently also write V equals IR, V equals RI. They're all going to be accepted. They should be, because if this was accepted, there's no reason why this one should be accepted. V equals IR. Okay, whatever. Okay, now, if I think I said okay 5 times there. Question 16. We have like what 12 questions left. Oh, thank you. Okay, we're gonna take 2 points. I need to stop saying okay. 0.5 and 20, and we're gonna take the origin since it passes through the origin. 0, 0. Now, you might be asked, why am I taking points? In an ohmic conductor or in an ohmic device in general, if it obeys Ohm's law, the slope is the resistance, given that this is on the x-axis you have the current and on the y-axis you have the potential difference or voltage. The M here, the gradient, is gonna be the resistance. Okay, so what we're gonna do now is, sorry, 20 minus 0 over 0.5 minus 0. Because remember, this is the slope y2 minus y1 equals to x2 over x1. 20 divided by 0.5 is 40, and 40 is your answer. Okay, question 17. This is memorization. This is potentiometer. What else did they say? Voltage device or rheostat. Okay, yeah. Basically, yeah, that's correct. Resistor, voltmeter. What is the other word for protective resistor? I've never heard of that, but whatever. Apparently, that's a thing. Voltmeter and the ammeter. Remember, the V is for voltmeter, A is for the ammeter. This large thing is always going to be a potentiometer. Okay, question 18. Which law does you memorize? Kirchhoff's second law. Okay, question 19. This is this is series circuit, and resistance, or sorry, yeah, resistance in a series circuit is additive. So 4 plus 5 plus 6, 6 plus 5 is 11, 11 plus 4 is 15. Question 20. The current. Okay, this is gonna be really easy. Just divide 40 by 5, or sorry, this is not the way you do it. Yeah, no, it is 40 divided by 5 will give you 8. So how did they get 12.5? The current. Oh, okay, wait. So this is going to be 5 over 40, not 40 over 5. 5 divided by 40 is 1 over 8, which is 0.125. Again, we're dividing by units. Okay, so this is the unit value, this is the unit value. This isn't with the suffix, not milli, micro, mega, whatever. So this is going to give us in amperes. Now they want it in milliamperes. So you multiply by 1,000, which means you move the decimal point 3 times. 1, 2, 3, 125. Okay, so for this question, we're going to do P equals I squared R. And yeah, that's what we're gonna do. However, you might notice we don't have our resistance. So what we're gonna do, we're gonna get the equation we've been using for the past 20 questions, and it's kind of annoying me how much I've seen this now. V equals IR. Okay, we're gonna find R. So R is equal to 230 over the I, which is 0.3. So 230 over 0.3. 230 divided by 0.3 gives me 766. Okay, now we're gonna multiply 766 by I squared, which is 0.3. So 0.3 squared wasn't 0.09? Yeah, it was 0.09. Okay, so times, so you do this on a calculator, 766 will give you 68.94, which equals to 69. There we go. Do they accept 68.94? No, they don't. Two rounds. Okay. 3 electric cells, each of EMF 1.5 volts, are connected into a form of battery. Okay, the EMF of the battery when they are correctly grouped in parallel. Parallel, again, the voltage is the same, everything else is additive. So 1.5. The EMF of the battery whose cells are currently grouped in series will give me the voltage is additive. So 3. So 1.5 times 3, 1.5 plus 1.5 plus 1.5 is 4.5. Okay. Two cells are in opposition to the third one. So you add 1.5 plus 1.5, which is 3, and then you subtract 1.5, which is 1.5 again. Okay, question 23. I'm gonna skip this because this is basically what I did. This is the rho L over A, and you just find the resistance by dividing this by this. I love physics. Okay, potential difference. Okay, what we're gonna do here, the current through 50 ohm conductor is 2 amperes. V equals 2 IR. If I see this one more time, 50 times 2, 100. That's part A. Okay, now E equals to QV. You're gonna want to find, you have V, you want to find Q. Q is IT. We don't have that. No, wait, Q equals, what was Q? Q was the charge. Q is equal to I. Oh, we don't have that. No, we do have the time. What am I doing? Q equals to I, which is 2 times 180. This is 360. Sorry, 360. Okay, 360 times 100. Because QV, and we have Q and V, is gonna give you 360, 36,000. Okay, now we're gonna remove 3 zeros, and this gives us 36. Because remember, where you have the unit value, 36,000 joules, we're gonna divide by 10 to the power 3 to give us the kilojoules. Question 25. Okay, whenever you see this, this is used to control the current, this bold thing, this thing, and whenever the long thing that's not like shaded is the potential difference. This is a potentiometer. Okay, question 26. This is the thermistor. You memorized its graph, and then you find the slope. I covered it. You find the slope for everything for some reason. As you can see, it obeys Ohm's law for a bit, then it deviates. So when it obeys Ohm's law, which is in the low currents, you're gonna want to find. So you take 2 points, 0 0.1 and 5, and 0 0. 5 over 0 0.1, 50 over 1, which is 50. Because remember this. If you're asking where I'm bringing these numbers from, 0 0.1 and 5, and the origin is 0 0. So then 5 minus 0 over 0 0.1 minus 0. 5 over 0 0.1, you do it on a calculator, you get 50, or you just do 50 over 1. Okay, 27. Shunt resistor. Okay, this is in voltmeter. Voltmeter, you connect it in series, and then since I have to go in 4 minutes, I'm just gonna cover the last 2 questions. You apply the same formula and you get your answer for this one. As I said, remember opposites, whatever, blah blah blah. The brightness of bulb 1 is greater than the brightness of bulb 2 because this is connected in series. You're gonna get the same current and you're gonna get the same current. Okay. And here, however, you won't get the same current. You'll get slightly less current. So that's why that. This is in series. They're all in series, so you're gonna have the same brightness. No current will flow if bulb 1 is unscrewed. I think they will. No, wait. Bulb 2 will light up. So yeah, it's only bulb 1 because if you unscrew bulb 3, you won't get. You'll have bulb 1 and 2 light. I'm not sure. I just choose number 1 as the safest option. Okay, that's the end of the quiz. Good luck, guys.